Hey everybody, and welcome to this new short video of my series dedicated to the myth-busting activities related to Azure SQL Virtual Machines. In this series we will go through some common misconceptions about Azure SQL Virtual Machines, and we will try to focus our attention on when you should choose a platform as a service approach for your SQL Server workloads instead of a virtual machines. Let's start by talking about some infrastructural topics and performance-related topics, because often customers ask me to distribute a virtual machine for their SQL Server instances, since they think that sizing a virtual machine in Azure is quite similar to what happens while sizing a virtual machine on premises, but this is not entirely true. When you want to define your virtual machine architecture in Azure for hosting your SQL Server instances, first of all, you need to define which kind of family and which kind of virtual machine series you want to use for your solution. Inside all these choices you can do here, you need to define what is the best virtual machine to support your workloads, considering that each one has its own peculiarities and its own drawbacks. This is not an easy task, because you need to understand well the infrastructure as a service topics on Azure. Additionally, when you are sizing your environment for a virtual machine in Azure, you need to define which is the right choice for your related to the storage subsystem of your virtual machines. You can again choose between several different tiers for disks, starting from mechanical disks and Ultra SSD, and as well as on-premise, the storage tiers can be your pain point for your SQL Server solution, so you need to do a good choice in this field. Then we need to put the two things together, because you need to attach your storage subsystem to your virtual machines, and this couple of things needs to be well matched between them. Otherwise, you risk to obtain poor performance or to waste your money trying to reserve high capacity disks that cannot be used in an inappropriate way by a small virtual machine, for example. This again requires you a good understanding of how things works under the hood in Azure Infrastructure as a Service. If you want additional details about this topic, I can drive you through my YouTube video where I talk about these topics more in details, or you can also have a look to the official documentation for a SQL Server virtual machine on Azure. On the other side, when we move to the PaaS offering, the things make simpler for you, because first of all, you need to choose the right purchasing model for you. You can go with the legacy one that is based on the database transaction unit model. Well, in this way, you need to acquire number of database transaction unit that is good enough to support your workload. Each database transaction unit consists of compute power or storage capacity or storage performance or memory, and you can have a complete abstraction in respect of the underlying infrastructure. You simply have to acquire the right number of DTU, and when this is not enough anymore to support your workload, you simply have to add more DTUs for your SQL Server service. On the other side, we have the vCore model, that is the currently Microsoft more recommended approach for your Azure SQL Database offering. In this way, you have a good flexibility between the storage capacity you want to assign to your SQL Server and its compute capacity. You can scale up or scale down both the compute power and the storage capacity in an independent way, so it's easy for you to reach the right configuration level that permits you to support workload with the right price tag. Additionally, since with this model you are able to define how many cores are currently supporting your solution, you can reuse your existing on-premises SQL Server licenses covered by software assurance by leveraging the Azure Hybrid Benefit feature. Now let's focus on the vCore model, where you can find more than a tier that can support your workloads. You can start with general purpose or business critical tiers that are available both for single database and elastic pools, as well for managed instances. You should use the general purpose tier when you deal with a budget-oriented workload that has no specific requirements in terms of performance, and the general purpose tier is based upon remote storage and can perform as well as a normal Azure SQL Virtual Machines with premium SSD attached to them. Included in the service, there's obviously the high availability configuration, but if your workload is more demanding in terms of performance, you can then switch to the business critical tiers, where you can find high performance storage layer based on local NVMe SSD, as well a more sophisticated high availability mechanism that can offer you also a read scale out replica. Then, if you have to manage a huge size database up to 100 terabytes right now, you can think about using a single Azure SQL database in the hyperscale tiers. Here, Microsoft made a huge work to redesign the monolithic SQL Server service and transform it into a multi-tier application that acts with a compute layer that is responsible to receive the requests from the customers and to process them, and it retrieves data from a remote from database that are archived upon remote data storage on an Azure storage account. Now, since the remote data storage is highly scalable and highly resilient but has not so much performance, normally you go through a row of page servers that act as SSD cache layer for your request to speed up the whole things. With this design, you can easily scale out your read-only replica up to 5 read replicas, and this is great for analytics workload. Additionally, you also have an independent log service that provides you the feature of persistent storage to persist the transaction to the storage. Last but not least, if you have to deal with an intermittent workload, you can approach the SQL Database Serverless tier. Here you can define a minimum number of vCores as well as maximum numbers of vCores that can support your workload, and then this tier can dynamically scale up and down between this minimum and the maximum depending on the workload requests. This can make you save a lot of money because you are paying only for the used compute capacity. And also this is the only one tier in the SQL database offering that permits you to pause it during the idle time for your workload. So this is another great way for you to save money during the off-peak hours. And I think that's all. As you can see, well, managing the sizing task of a virtual machine can be a challenging task here. You need to understand very well how things work under the hood, but also with the platform as a service, you cannot abstract yourself too much from the underlying infrastructure, because with the vCore model you can choose between several tiers, and you need to understand how things works to make the good choice, the right choice for your workload. Anyway, a huge difference in this context is the speed and the agility you can use to change the tier with the platform as a service offering. While if you need to rescale your Azure SQL Virtual Machine, you probably also need to intervene at the storage level, and this can require some management task that requires effort for you. With the PaaS approach, you can easily scale up or scale down your resources just in a couple of clicks. And so this is the added value for the solution in this context. Okay, I think it's all. I hope to see you soon in the next video. In the meanwhile, if you wanna stay in touch with me, just follow the link about me.homecamedlab.com. See ya! Ciao, grazie!